Okay, this lesson is about trigonometry and bearings. So using some of our information from last week on angle of elevation and angle depressions, this can help us. This is really good with people who are on boats and using compasses, looking at directions. So we're looking at our compass where we talk about north, east, south, west, the never eat soggy waffles. Okay, so in trigonometry, we get to use right triangle trig to help us solve compass type problems. So it says in surveying and navigation, directions can be given in terms of bearings, right here. A bearing measures the acute angle that is a path or line of sight, makes it a fixed north-south line. Now what you need to remember, acute angle is always an angle that is less than 90 degrees. Okay? So for instance, how you read the first angle here is you say you are 35 degrees east of south. That is how you correctly state a bearing. So if you look at the next picture right here, here is your acute angle, 80 degrees, going back to your north-south line. Okay? If you look which direction you are, you're in the north and the west quadrant. Okay? But what you say is you say that you are 80 degrees west of north. So you always say your right, left, or your east, west first before you say north, south. Then look at this last example. This is a 45-degree acute angle back to the north-south line, and that's 45 degrees east of north. So let's do an example together. Okay, so here's this example that says flying 600 miles per hour, an airplane has a bearing that is 34 degrees east of south. After flying 3 hours, how far south is the airplane? So the first thing you should do is draw your compass. So never eat soggy waffles, okay? So we know it's in the east-south quadrant, which means it needs to be somewhere in this fourth quadrant down here, right? Because we know it's somewhere over here. You always draw your bearing out of the origin, okay? So you're drawing. This is the flight the airplane's taking, okay? So we know on this flight, right now, the airplane is flying 600 miles per hour. The question is, how far south is this airplane? So what you do is you draw your line back to your north-south line, and your angle comes from the interior of this triangle back to the north-south line here. This is your 34 degrees that is east of south. The question is, how far south is it? Now it says it's been flying for 3 hours. That means we actually want to know the distance it's going, because that's what the final question is how far. So we need to find the distance. This is a rate. That is not a distance. Well, to find a distance given a rate, you need time, because distance equals r times t, which is rate times time. So if we know the rate is 600, and it tells us right here the time is 3, then we know the distance the plane is flying is 1,800, okay, miles. Now, that's not our answer. Our answer, again, is how far south has it gone? So this is where we need to think about SOHCAHTOA here. If we look, we can see that we've got the angle, we've got the hypotenuse is given, and it's our adjacent side is what's missing. So of SOHCAHTOA, it's actually the cosine of 34 degrees, make sure you're in degree mode, equals the adjacent side, which we'll call A, over the hypotenuse of 600. So to solve, we're going to multiply 600 to both sides here. So that's 600. Okay? In your calculator, just do 600, or on Desmos, or on your cell phone, times cosine 34 degrees. and you should get your angle to, or not your angle, so your distance, how far south is 1492.27 miles. Okay? Okay, I have another one that I want us to look at. This is problem 31. Okay? So just a little challenging, but it's not going to be as hard as what you're going to be working on. All right, so let's read the problem. It says, a surveyor wishes to find the distance across a swamp. The bearing from point A to point B is 32 degrees west of north. So we're talking about right here, okay, going this direction. The surveyor walks 50 meters from A, and at a point C, the bearing is 68 degrees west of north. Find A, the bearing from A to C, and B, the distance from A to B. So what we're looking for is what is the angle from A to C here, and what's the distance from A to B here. Okay? So on this type of problem, I have got to redraw this. So I'm going to think about A. I'm going to put A over here, down in this corner over here. Okay, and I'm going to label my origin A. I know, leaving out of my origin A in the northwest direction, so never eat soggy waffles, I know I've got an angle going over here. And what I know is the angle, because remember you have to always go back to your north-south line, right there is 32 degrees. Okay? I know somewhere over here, my end of my red line has to be point B. Okay? Then, I know somewhere going out of A, which means it's going to come from the northeast side, but we just don't know where, is going to be 50 meters from here, so 50 meters from here, is going to be C. And what I'm going to do over here is I'm going to draw my compass. Never eat soggy waffles. Now, it tells me the bearing from point C to B is 68 degrees west of north. So that tells me, again, I've got another angle over here, and this is coming from this side, 68 degrees. So that's outside this, but I can figure out that angle is right inside there. So that means somewhere way over here, where these two meet, has to be B. And so the question is, right here, is what's the distance from A to B? Okay? So we got to think about some angle information and 180 degrees and 90 degrees and stuff like that. So we know right here, this is a right angle. Okay? And we know we've got some alternate interior angles happening right here. So if this is 68 degrees, we know on the other side of this angle, okay, we know down at the red and blue right here that this has to be also a right angle over here. Okay, so if this is 32 degrees, then 90 minus 32 is going to give us the other remaining angle right here, which is 58. So we know this is 58 degrees right here. Okay, so we know our right angle here, and we have a side leg, but we need another angle to help us find this missing part right here. Okay, so if we know this is 58 degrees, by alternate interior angles, the angle up here also has to be 58 degrees. Okay, and we know 58 degrees plus this angle has to be 90, and then 68 plus that angle has to be 90. Well, what is 58 take away 90? Is we know it's 32 degrees right here. Okay, and now we've got 68 degrees on this side, and you know this forms a right angle, this whole angle right there. So what's 90 take away 68 degrees, well, that gives you 22. So that means this side is 22 degrees. Well, then we have enough information that our missing angle that we need for our triangle is 22 plus 32. So this is 54 degrees. Now we have an angle, now we have a side, and now we can use SOHCAHTOA to find this missing side. So we have our angle here, that's what we're going from. This is our opposite, and this is our adjacent, because remember the hypotenuse is down here on part A. So we've got opposite and adjacent. So that means we're going to say the tangent of 54 has to equal x, the opposite, over the adjacent of 50. Okay, we're going to multiply both sides by 50, and then we get x is equal to 50 times the tangent of 54, which gives us 68.82 meters. Okay. Now I was asking, what's our angle from A to C? And we actually already knew it because it was this angle right here, which we found was 58 degrees. So our angle from A to C is 58 degrees. Okay, now you're going to practice some problems. Okay, you're going to do the bearing examples that's attached to this video, and it's 6 problems, and I will show the answers when we meet. Okay, have a good day.